Hi everyone, welcome to my talk. I didn't expect to have so much people, so that's cool. First of all, I would like to introduce myself. I'm Jonathan Roquelaure, and I'm a solution engineer at JFrog. So as a solution engineer, I used to work with our customer to help them to improve their architecture, to help them to use our product to fit their needs for their use case. And I'm also working a lot with the community, going on conferences, making some talks, webinars, etc. What's Frog? So frogs are people working in Israel, in the US, or in France, and it's also a tiny animal which has the cool characteristic to always leap forward. It never goes backward. And so we are also a company at JFrog, and we have 4 products. First one is Artifactory. Maybe you already know this product. We have also Bintray, our distribution platform, and Mission Control, and also the latest one, X-Ray, for analysis of component for security, license check, etc. So basically, we are a company focused on binaries to take care about your binaries, help you to distribute them, to manage them, etc., etc. I would like to start with a quick question. So since about 2 years, we are all talking about Docker. We heard a lot about Docker. It's Docker, Docker, Docker everywhere in every conferences. And today I'm here to talk about it. So first question, I would like to know, and if you can raise your hand, it's to know who already heard about Docker. Oh, yeah, everybody, okay. And who did the tutorial of Docker? Okay. Who did some POC, playing with Docker Compose, Warm, maybe doing some advanced stuff? Okay, still a lot. And now, who's running Docker in production? Oh, there are some people, but not so much. And that's because that's a thing we heard a lot with our customers. Many customers are asking for Docker registry support in Artifactory. They are asking for how to manage Docker, what are the best practices, etc., etc. And they are working with Docker since 1 year, 2 years, but there are not a lot who are doing Docker in production, which are running Docker in production. And what they told us is they like Docker, they like the concept, they love it, but they don't trust it enough to put it in production. And so we try to figure out to help them to trust, to have more confidence in Docker. And so today the talk will be about how you can be more trusty with Docker. And I will use Artifactory to show you some demo and some concepts. But the main idea is not about Artifactory, it's about managing binaries in the proper way and how to manage Docker image as you manage any binaries by building proper pipeline. So why we are good with Docker and why Artifactory can be a good product for Docker, Docker is no more than another kind of binary. A Docker image is just binaries, and we have decades of experience with binaries. This is our job. Also, we did the first image registry, even before there was a Docker registry. And we provided the first private Docker registry, even before the official Docker one. Also, we are doing promotion pipelines for Docker as we are doing promotion pipeline for all other kind of technology. So, yeah. Another interesting thing is about why you can consider using Artifactory with Docker is that nobody is using Docker and nothing else. Docker is container technology, and a container is to ship something. You will not use Docker without anything else. You will use it to ship some Java application, to build microservices, to do things with other technology. And yeah. So it makes sense to have a solution for all this technology. So the goal for today will be to develop and to understand how you can create a lifecycle for Docker containers. And now we have the goal. we will start with a quick question. Do we have an existing pattern for lifecycle of binaries, and do we need to adapt it? So I'll let you think about this. Do you think that Docker is more like a Docker image, a Docker container is more like a Debian package, or a Java war archive? So just as a quick reminder, a Debian package is an app with a declaration of dependencies to resolve, where a Debian, a Java archive will be more an app with all the dependencies wrapped up in the binary. And in fact, this is Docker. Docker comes with everything, all the dependencies inside the image. So that's a good news because we are doing pipelines for Java war file since years. So that's a good thing, and we can start to look at how we are doing it for Java. There is one important concept when you are doing pipeline. It's the concept of quality gates and visibility. So I don't know if you're familiar with this diagram, but we really like it at JFrog. So the idea is every step, every staging area is isolated from the other one by a quality gate. A quality gate is simply some condition you want to be able to resolve and to fit with to move to the next step. So the first quality gate is simply, should I commit my code? What are the conditions I have to fill to be able to commit my code? In general, is running the unit test on my machine, making some free tests on it, extras, then I commit my code, then I go to the stage, the development environment central, which will be like a Jenkins, a CI server, whatever, which will be doing some other tests, some unit tests, but some code coverage, etc. And you promote your binaries like this from stage to stage, passing through all the quality gates. Also, a classic CI/CD pipeline for software is something like this. You have some developers using a build tool with a dependency manager, and they're using it to resolve dependencies. They'll go through a repository manager. So because now I think everybody understands why you need a repository manager. And this repo manager will go to the internet to get the external dependencies. It will be bring to the developer. And after testing on its own machine, it will commit the change. Change will be taken by the CI server, like Jenkins, for example, which will run the same build with the same build tool, same dependency manager. And so it will resolve dependencies through the repository. And at the end, it will publish into the repository some artifacts, generated artifacts, and all the build information relative to the build. And from that point, you can start to use third-party tools like Selenium, JMeter, or a QA team member to get your artifacts from the repository, test them, qualify them, and contribute with metadata, and promote them through the different stages. And once you are at the last stage, you can choose to distribute your artifact with a solution, so directly to your production server with orchestrating tool, or you can directly distribute them with, for example, Bintray, which is our distribution platform. Okay, so that was just for the main concept. Now, let's go back to Docker. And the first thing, do you know why this guy is happy? He's just run his first Docker build. And I don't know for you, but when I made my first Docker build, I was so amazed. I was, wow, it's so simple. I don't need any more ops guy. I can run my server apps, etc. It's so easy. And so when you start to play with your first Docker file, to create some things with it, you feel like, yeah, you want to do some Docker build everywhere. You want to do it in every environment. It's so easy, it's fast, it's cheap. That's wonderful. And so first thing, when you think about the diagram before with the pipeline, you can have the temptation to do something like this. To say, okay, I will run my Docker build on my machine, and my Jenkins server will just take the Docker file and run a Docker build, and then on the test environment, I will do it again, etc. So you will just run Docker build in each environment. It's fast, cheap, and this is not always the way to go. Fast and cheap builds are not always the way to go. And that's why. In fact, if you look at a Docker file, and you start from getting a base image. So here it's an Ubuntu. When you say from Ubuntu, you will have the latest image. This is what it means. And then you're getting the latest Python version with the apt-get, latest Node.js, etc. All are the latest version. So on each environment, you will have the latest version. And for the base image, for example, if there is a new version of Ubuntu between the time you move from your production mirror environment to your production environment, you won't have the same Docker image at the end on the two environments, which is not good. So to fix it, you can specify which image of Ubuntu you want, for example, the particular tag of the base image you want to use. So this can be an ID. It looks better, but sometimes what happens is there are some security patch on base image, and the maintainer of the image will upgrade the Ubuntu 14.04, and you will not notice it. So you still will have different images in your different environments. So you can fix it again by using the hash of the base image, so the SHA-2 of the base image, and now you're sure that your Docker file will build always with the same base image of Ubuntu. That's cool, but how about those? How about Python, the apt-get install, etc.? How you can control that you're sure in each environment you will have the same version, and what you are testing, the image you are testing, is the same you will put in production. Because this is one of the reasons why you don't trust Docker when you are doing this naive approach. It's if you are doing the Docker build on each environment, at the end, the Docker image won't be the same, or at least you will not be sure that you will have the same Docker image. And so you will test something which will not be the one you put in production. And this is really important. What we want to have is something like this, a build at the beginning of your pipeline, and to keep the same binary. And it's not only for Docker, but keep the same binary for each environment. And improve this binary in your staging environment, improve it in your testing environment, in your production mirror environment, to be sure that what goes in production is what you tested. Okay. Another interesting thing by this interesting guy is the concept of immutable and stable binaries. So I don't know if you're familiar with this concept. I guess yes, but let's remind it. So a traditional server pattern is something like this. So you package a server image, you provision your server instance, and at the moment you need to apply some configuration changes, and then you have another changes to do, and so you apply configuration changes, and again, and again, and again. And at the time, it starts to be really ugly, it doesn't work really well, and so you have to break everything, to package a new server image, and start again, and you iterate like that. The concept of immutable server pattern is different. The idea is that you package your server image, you provision your server, and if you need to do some changes, you will not apply changes on your actual server. You will start again with a new package for your server and provision again. This is there is a real great article from Martin Fowler about this. So yeah. So for Docker, it's we want to apply this. So the idea is not to only use container, but to have the same container the whole way, and to be able to recreate the whole server really easily and fast. So to have a really fast and efficient pipeline. So for today, what I will do is I will build a simple application, containerized application. So just a side note, I changed a bit the demo for today, like yesterday, to apply what Josh said. So I decided the original talk was about a WAR file inside a Docker image containing a Tomcat and Java. I changed it to make jar and not WAR, as he said, with a Spring Boot application. So we will use a base image with Nginx based on JC, the latest official image of Nginx. We'll add some Java. This will be our base framework image. And then we will add inside it the result of a Gradle build, so the Spring Boot application for the web services, and an NPM build for the UI, so a front-end and a back-end application inside it. So what we want to do, some requirements about this pipeline. First, the application, the jar, so the UI and the backend must be tested and have final deployment in container. We want to test them in container and we want to deploy them in a container. Then we want to know that the framework we will use, the base framework image is good, but we want to be able to address vulnerability. So we want to be able to upgrade it. And also, of course, we want to have isolated updating process. We want to be able to update the base framework layer, or we want to be able to update the application independently. So to do that, we will have several pipelines. The first one will be the Gradle pipeline, which will build the web service application, the jar file. Then we will have, of course, the UI pipeline. I didn't write it, but we will have the framework build. So the framework build will take the base image, the Nginx base image, will add Java and run some security tests. And at the end, we will have an integration build. So it will take the base framework image, it will add the Gradle build, and the result of the NPM pipeline. So let's have a look to the different pipelines. So for the Gradle build, it's something really simple. I think we all doing this all the time. So we'll build the Gradle project, run some unit tests, deploy it to Artifactory, and after testing it in containers, we will promote it to release. If we have a look to repositories, so this is where Artifactory comes. So we will deploy at the end of the build and running unit tests, we'll deploy to a development repository. So the libs dev local, which will be part of a virtual repo, libs dev. And the promotion at the end of this pipeline will be a simple operation of moving the generated artifacts from the dev repository to a release repository. For NPM, it will be quite the same, just the name of the repo will change, but it's exactly the same concept. And now for the framework build. So for Docker, what we will do, the first step will be to pull the latest Nginx image, to run the Docker build by adding my Java inside my image. And after that, I will test it by adding the latest stable version of my Gradle build and my NPM build. So the latest stable version of my application inside my container to be sure it works with the latest stable version of my application. And if it works, I will deploy this base image, this framework image onto Artifactory and promote it to release. So in terms of repo, I will start with the first step to pull Nginx, run the Docker build, and if it's built well, I will directly deploy it to a dev repo, because I want to keep the trace of all my builds, all my development builds. And then I will take this image, inject the latest stable version of my Gradle and NPM builds. So I will get them from the lib release, so the artifact that has been promoted during the first pipelines, the application pipeline. And I will run my tests, etc. So let's start with the beginning. So first step, I will build my project. So, and I will do it with Docker for Windows, because I love challenging and risk. So I will do all my demo on Windows. So first thing I will show you, I will sit, it will be better. Okay. So first thing, I will enter in my Docker framework workspace, and here is my Docker file. You can see it's something really simple. It's simply from the Nginx latest. I get it from Artifactory, and I'm adding Java. I'm registering Java in the path, and at the end, I'm just starting Nginx. Nothing too complicate. And so I'm gonna build this. So first step, I'm gonna build this image. Okay. And I'm building it with the tag 1. If it works, please, God of demo. That's what happens with when you want to play with Windows. Okay. Yeah, it's what I'm doing. Looks good. Okay. And nothing go. Okay. I will start with a new PowerShell. Okay. Workspace, Docker. Ah, cool. Thank you. It was just time to wake up the machine. So, it's now copying the file. And while it's building my image, I will go back to the slide just to explain the next step. So after building my image, what I want to do is to test it. So if I want to do it properly, of course, this won't be manual thing. It will be done in my CI server like Jenkins. So the first job will be to build the image, and then it will trigger another job, which will be the framework test. So this is the job I will do now. So the idea is to take the build image, to inject the latest stable application, and to run a standard test. So to do that, my image is built, and so what I'm gonna do first is I will push this image to my Docker dev local. So I'm pushing to my Artifactory. Okay, and in the same time, I will show you a bit of the structure of my repositories in Artifactory. So I will connect as an admin. Okay, and if I filter on Docker here, you'll see I have two virtual repositories in Artifactory, a Docker Dev virtual and a Docker Prod virtual. Now I'm pushing to the Docker Dev virtual, which contain several repositories, a remote repo which is going to Docker Hub to be able to resolve my base image, my Nginx base image, Docker Dev local, and Docker Prod local in case I want to resolve some released images. what is important is there is a default deployment repository to allow me to deploy to this virtual repository, and at the end, the image will be deployed inside my development local repository. The second virtual repository for Docker is a Docker prod. It contains 2 repos because I choose to have a strong isolation between my production repository for the base image, the framework, and the repository for the Docker application, the final image. But what is important on this one, there is no default repository for deployment, which means that I won't be able to push an image to my Docker prod repository, because I don't want anybody to be able to directly push something in my release repository. I want to do that through a promotion by copying from development to production. So the push has been done, and I will just do another quick thing here. I will yeah. So I will first remove the curl alias in PowerShell, okay, and run a curl command to retag my my Docker image in Artifactory. In fact, the idea here is just to have a latest. So I will show you the retag file. I'm just saying to Artifactory, okay, I have a Docker framework image with the tag 1 in Artifactory. Now I want to make a copy and to have a new tag latest on this image to be able to consume it by running a Docker pull, Docker framework latest. And now I'm gonna do a really quick test just to be sure my image is working. And so I will run this image. So as you can see, I'm pulling the Docker framework latest. So I will consume it from Artifactory. Okay, and I will just make sure that if as I'm exposing the port 8000, if I go to my local host on port 8000, okay, welcome to Nginx. It's okay, it's the only purpose of this base image. There is also Java on it, so this will be the framework test job. So let's go back. Now it's time for the framework test. So I will get my application and build a test image to check if everything is working fine. To do that, I will go back to my PowerShell and git my container. Okay. And now I will enter in the framework test folder and build a new image. So this image will contain is based on my base image. So my framework my framework, Docker framework latest image, and I'm copying inside it my jar file and all my UI projects, all the front-end application. So it's now downloading, and after that it will I will run the container and make sure that everything goes fine all together. And if everything works fine together, after testing, I will finally have the final step for this pipeline, so I will be able to promote from my Docker dev local to Docker prod local. It's a bit longer, okay. It works fine. Just to show you in Artifactory, so if I go back in my artifact here into Docker dev local, just to make sure, yeah, I have my Docker framework with the tag 1 and the latest one. So that's cool. Okay, build is almost done, so it's adding the jar. Yeah, also I'm adding some configuration for Nginx to reroute requests to the web service. And now I have my image, my test image, and I will run it. So run it, exposing the ports. So I can see Nginx, Spring starting. And now if I go to my localhost app index, here it is. This is my application. It's a really simple application showing our good friends. So that's cool. So now I tested my stable application with my Docker framework. And so what I want to do is to promote my Docker framework to release. So to do that, I will use a simple call to the REST API, to the Artifactory REST API. So let's do it. And okay, I provide my password. And that's it. So now if I go back to Artifactory and I go in Docker prod local 2, yeah, here it is. I have my Docker tag 1 and my tag latest. I promoted both images because I want to keep both in my production repository. So that's cool. For the first Docker pipeline, that's done. Now, the application delivery. So the idea here will be to consume the released Docker framework, the dev Gradle and dev npm builds. So not the released one, but the development one, to merge them together in a new Docker image, to test them, and if everything is fine, I will promote everything, my Docker image, my Gradle, and my npm build to the final release. And if and after that, I can do a final step if I want to promote everything to a distribution repository, which is a concept in Artifactory linked to Bintray. So by doing that, you will directly distribute your Docker image, your application with Bintray, or you can start to consume them with some orchestrating tools to deploy them to production. So in terms of repositories, so this is how it works. So I will consume my just built Docker framework image from the Docker prod repository. So it will come from my Docker prod local 2. I will consume my development application from the libs dev local and npm dev local. I will build everything, push them in a Docker development repository, take them from here, build an image with test it, and then if everything goes fine, I will promote everything. So I will, in the Docker dev local, I will promote my Docker app image to Docker prod local. So for the first one, let's do it. The first job. So, okay. First of all, I have to move out of this. I will go in my cd Docker app. So here is my Docker file. Nothing really complicated. And so I will run the build, the first step. So first step is to build a new image of my Docker app. And of course, it will take some time to start. But while it's starting, I will show you. So after the build, it's exactly the same concept as the first pipeline. So after the build, I will push it to my dev repo. And get them from the dev repo, test it, and promote it. Okay, still not so slow. Thank you. So it's starting. It should be quite fast because everything is already on my local machine. So that's cool. And now I can push my Docker image before to test it. So I push it to my dev repository. And after that, okay, it's waiting. Oh. Okay. It's waiting. After, I will do the retag also as I did before, just to have the latest image available. So, Docker retag, is it okay? Okay. Okay, still pushing. Takes a bit of time. And so I will, before to test my application, I will just retag it, my image from 1 to latest, as I did for the Docker framework. And after, I will jump to the test application job. So yeah, as I explained before. And it's quite slow. So yeah. It should start to be here. So in my dev local, if I refresh it, I should have, so yeah, it's still in upload process. Can see my layers coming into my Artifactory. Okay. What I'm gonna do, in fact, is simply running the test while it's pushing. Save some time because I think you get the concept. Okay. So let's go to my Docker workspace. Yep. Oh, it's done. So it was not so fast. So far, so good. It's work. So now I'm retagging. My Docker image inside my dev repository. So it's the same I did before. Okay, provide my password. Oh, can't open retag JSON. Why? Okay. Yeah. Why? Okay, I have an issue with this file. Okay, I will do without it. It's just a retag. It's not mandatory for my for this. And so So now what I want to do is to test it. So I will not test the latest with latest tag. I will test with the tag 1, the image I just pushed to Artifactory. And so I'm just running the container. And of course, there is a conflict because I already have a framework test. So I will remove this container. Okay. And I'm running it. So it's starting Nginx. In fact, it's exactly the same thing I did. The only difference is here I'm using the development version of my application. In this case, they are the same. The latest development version of my application, my front end and my back end are the same as my latest stable version, my release version, because I didn't run it now. But this is the main idea, the main difference between the first test I made and this one is to use the development version. And so as my tests will be the same, simply go to my application and check if it's still running. It is. So I'm satisfied with this. I will promote my my image to the production repository. Okay. And after that, I will be okay. So now I should promote everything to release and distribute my stuff. But here is the main idea. So what's going next? Just an overview of the whole pipeline. So we have, once again, there is no the UI pipeline, the front-end pipeline, but it's really similar from the Gradle build. So the idea is to have different entry points. So if you commit something on the Gradle project, it will trigger a job, your Gradle build. So you will compile the Gradle project, run the unit test, deploy it to Artifactory, and this will trigger the framework test pipeline, which is on the bottom in orange. So this will build the framework image with the latest jar and latest JS application, run some tests, and if everything goes fine, it will promote everything. You have the same if the entry point is a security patch, for example, the maintainer of the framework base image, a new update on it, so it will trigger the Docker framework pipeline, and it will follow the blue path. So by building the image, deploying it to Artifactory, testing it, promoting it to release, and building the Docker app, testing it, and promoting everything. One really important thing in this pipeline is automated tests. This is everything. If you don't provide automated tests, this will not work. You will lose all the control on your pipeline, and you will not have control on what you are doing. So for the demo, I didn't provide any automated test because it will take too much time for me, but it's really the key on this kind of pipeline. Maybe some of you will ask if with such kind of pipeline with 4 separated projects dependent to each other, etc., we can reach a point with some jam and something where your pipeline will be blocked. In fact, what can happen is, for example, if you have a security fix on your base image that with a non-backward compatibility with your application. So you have a security fix, and your application will not work because of that. So in this case, you have just to think a bit in advance to it and improve your application, changing the things to be able to make it compatible with your new image with a security fix. Test it with the old environment because it should work, or it will still work with the old environment. And so by testing it, you will be able to release the new application and restart the pipeline for the Docker framework image. In very, very rare case, to be honest, I never seen that, but I heard about such case, you can reach a moment where your API becomes so insecure that you have to build an entire new one. In this case, you will have to stop all your pipeline and to do a manual first step of building your application and moving it from dev to production, just to reinitiate the whole pipeline. But this won't happen often, for sure. And at the end of the day, you will have, with such pipeline, you will have something which will run really smoothly and on an automated way, with the front-end developers pushing their code into the VCS, and this will upgrade the whole application in the same time. It will be the same for the back-end developers, for the security guys maintaining the Docker framework image, etc. So this, it's full automation. And if you remind immutable server pattern we were talking about, I think we did it. It's, I don't know, what do you think? But yeah, and the key here is, with the immutable server pattern, is to reach a point where you have an absolute trust in your software. You know exactly what you are moving to production. You test all the things, and you know that in every stage is under control. Every part of your software is under control, and every part of your software has been tested in the exact same condition that will be your production at the end. So yes, we did. And just to finish this talk, I will show you, because it was a bit a shit, because I didn't, I did only Docker push and pull command on my machine for my PowerShell, but I didn't show you any pipeline in Jenkins. So I don't have the full pipeline. In fact, I don't have the interaction between the different pipeline. But in here I have a Jenkins with some pipeline integrated with the Artifactory Jenkins plugin and the DSL pipeline for Jenkins. So for example, for the Docker framework, here can be an example for the pipeline. And I don't know if you will be able to read it. Maybe it's too small, but you can see it's really, it's something really easy to do to manage this pipeline. So it's simply calling some object coming from our plugin to instantiate the server, to instantiate a build information object, to be able to have a full traceability about your build, and to link your build image to a build information, to maintain the history of all your artifacts from development to production. Then you use simple Docker objects which come from our plugin and which allow us to have a traceability of all used dependencies, like the base image, and also, of course, the image you pushed during the build. And at the end, you simply publish the build info. Then you're doing some tests, so I have to do that. And the promotion is just like I did on my machine, a simple declaration on from what repo to what repo you want to copy your file, which will be if you want to attach some properties, etc., and just call the promote method, and at the end call I'm retagging my image to be the latest one. And of course, I have also the same for I have a npm pipeline here doing my UI pipeline, and the Gradle pipeline also is here, and the Docker app also. So yeah, and just so yeah, the conclusion: release fast or die. This is a sentence we love, but I like to add release fast or die, but don't lose control over what you release. That's all, folks. Okay. So, do you have any question? Yes. Oh. Yeah. Okay, that's the question. So the question is why I don't delegate the configuration, the integration part to some configuration tool like Puppet, Ansible. Yeah. So this is because of the immutable pattern. This is the idea, to not reconfigure the things at the end. What you want to have is to have something that you build at the beginning, and this is the same exact image that will move to all the stages. So this is exactly the subject of the Martin Fowler article I have in the link, which writes about this practice to reconfigure the things in each stage instead of rebuilding everything already configured and packed. So that's why. Another question? Oh.
Do you have any thoughts on scale? What if I maintain a base image for a company that has hundreds and hundreds of applications, and I want to do daily security patches?
Okay, so yeah, if you have so yeah, this during this talk it was pretty simple because the base image was only used for one application. But now, what happens if you have hundreds of applications depending on your base image, and you want to have security patches on a daily basis? It will be exactly the same. Just you will have more pipeline, but it's what you have to understand. It's really an independent process. With this kind of pipeline, the base image upgrade is and has to be really independent from the application upgrade. So with this kind of pipeline, and this is why you need this kind of pipeline, it's because as a security guy, you will be able to do as much security patches as you want. You will be sure by the pipeline, the automated pipeline, that it will work with all the application. And if it's not, you will have a really quick feedback. Or the guys maintaining the application will have a feedback, and they will be able to rewrite or refactor the application to fit the new security patch. You're welcome. Yeah, this is exactly the, if you remember, yeah, it's here. The immutable server pattern, this is the purpose. You don't change the configuration on an existing container, on an existing server. The idea is to, if you have to change something in the configuration, rebuild it. Do it again from the beginning. Because if you start to change the configuration one day, then for sure you will do it again for the next day, and again and again. And you will reach a point where you will lose the first thing you built, and you will have a stack of changes, a stack of configuration changes.
When you have your configuration version, also this could be I mean, this could be also.
version your configuration, and also sometimes this solution is also better than rebuilding all and losing time to build and test at a time.
Yeah, but I agree. That's a common idea to say that a server should be up all the time. This is really common, and so a server should be up all the time. So you will just add configuration and manage all the history of your configuration changes by adding them. But for sure, by experience, there will be one day where you will have to rebuild your server. It will crash because of some reason, for sure. And so you will have to apply all the history of your configuration. And this rebuild of your server will take a lot more time than to have a simple pipeline that is building a new server each time you want to change your configuration. Because your pipeline will be more effective. And moreover, this pipeline, you will have built it in advance. So you will have think about it in advance on how to have an effective pipeline to distribute fast a new server. Because you will do it every day instead of waiting 10 years before say, oh, I have to make it again. And it will take maybe 1 day, 2 days, 1 week. You don't know. So thank you for the question. But it's an interesting debate. Yeah. We have 4 minutes left, so if you don't have another question, no? So thanks a lot, and see you soon.